100 Facts about Radiation Detectors in Radioactivity. Historical context. 1. Early detection. The first radiation detector was the photographic plate, used by Henry Becquerel in 1896. 2. Marie Curie. Marie Curie's pioneering work in radioactivity led to the development of more sophisticated detectors. 3. Geiger counter. The Geiger-Müller tube, commonly known as the Geiger counter, was invented in 1908. 4. World War II. The Manhattan Project spurred significant advancements in radiation detection technology. 5. Nuclear power. The advent of nuclear power plants necessitated precise and reliable radiation monitoring. Types of radiation detectors. 6. Ionization chamber. Detects radiation by measuring the ionization it produces in a gas. 7. Geiger-Müller tube. A type of ionization chamber that operates in a pulse mode, producing a detectable electrical signal for each ionizing event. 8. Scintillation detector. Converts ionizing radiation into light, which is then detected by a photomultiplier tube. 9. Semiconductor detector. Utilizes the electrical properties of semiconductors to detect radiation. 10. Proportional counter. Similar to an ionization chamber but operates in a proportional mode, amplifying the signal. 11. Film badges. Contain photographic film that is darkened by radiation exposure. 12. Thermoluminescent dosimeters, TLDs, store energy from radiation, which is released as light when heated. 13. Optically stimulated luminescence dosimeters, OSLDs, similar to TLDs but use light to stimulate the release of stored energy. 14. Neutron detectors, designed specifically to detect neutrons, often using nuclear reactions. 15. Radiation portal monitors, used to detect radioactive materials in people or objects. Applications of radiation detectors. 16. Nuclear power plants. Monitor radiation levels to ensure safety and compliance. 17. Medical imaging. Used in X-rays, CT scans, PET scans, and other diagnostic procedures. 18. Radiation therapy. Monitor radiation dose delivered to patients during cancer treatment. 19. Nuclear medicine. Detect and measure radioactive isotopes used in medical research and diagnosis. 20. Environmental monitoring. Measure radiation levels in the environment, including soil, air, and water. 21. Industrial applications. Detect and measure radioactive materials used in various industries, such as manufacturing and research. 22. Security. Used in airport security and other applications to detect radioactive materials. 23. Space exploration. Monitor radiation exposure to astronauts. 24. Archaeology. Date artifacts using radioactive isotopes. 25. Geology. Study the geological history of Earth using radioactive dating techniques. Detector characteristics and principles. 26. Sensitivity. The ability of a detector to detect low levels of radiation. 27. Energy resolution. The ability to distinguish between different energies of radiation. 28. Efficiency. The percentage of radiation that is detected. 29. Dead time. The time period after a detection event during which the detector is unable to detect another event. 30. Background radiation. Radiation present in the environment that can interfere with measurements. 31. Ionization. The process of creating charged particles, ions, when radiation interacts with matter. 32. Excitation. The process of raising electrons to higher energy levels in atoms. 33. Fluorescence. The emission of light by a substance after being excited by radiation. 34. Phosphorescence. The continued emission of light after the excitation source has been removed. 35. Photoelectric effect. The emission of electrons from a material when it absorbs electromagnetic radiation. 36. Compton scattering. The scattering of photons by electrons, resulting in a loss of energy. 37. Pair production. The creation of an electron-positron pair from a high-energy photon. 38. Nuclear reactions. Processes that involve the transformation of atomic nuclei. 39. Half-life. The time required for half of the atoms in a radioactive sample to decay. 40. Decay rate. The rate at which atoms in a radioactive sample decay. Detector calibration and quality control. 41. Calibration. the process of ensuring that a detector is providing accurate measurements. 42. Standards, reference materials used to calibrate detectors. 43. Quality control, procedures to ensure the reliability and accuracy of detector measurements. 44. Detector maintenance, regular maintenance to ensure proper functioning. 45. Regulatory compliance, adherence to regulations governing the use of radiation detectors. Health and safety considerations. 46. Radiation exposure, the amount of radiation absorbed by a person. 47. Radiation sickness, health problems caused by excessive radiation exposure. 48. Radiation protection, measures to minimize radiation exposure. 49. Shielding, materials used to block radiation. 50. Distance, maintaining distance from radioactive sources reduces exposure. 51. Time, limiting the time spent in areas with high radiation levels. 52. Alarmism, avoiding unnecessary fear and anxiety about radiation. 53. Risk assessment, evaluating the potential risks associated with radiation exposure. 54. Dose limits, regulatory limits on radiation exposure for individuals. 55. Emergency response, plans and procedures for responding to radiation accidents. Advanced topics. 56. Spectrometry, the measurement of the energy distribution of radiation. 57. Imaging techniques, methods for visualizing radiation sources and distributions. 58. Dosimetry, the measurement of radiation dose. 59. Radiation transport, the study of how radiation moves through matter. 60. Monte Carlo simulations, computer models used to simulate radiation interactions. 61. Neutrino detection, specialized detectors for studying neutrinos, elusive subatomic particles. 62. Dark matter detection, experiments searching for evidence of dark matter, a mysterious form of matter. 63. Radiation therapy techniques, advanced methods of delivering radiation for cancer treatment. 64. Nuclear waste management, technologies for safely storing and disposing of radioactive waste. 65. Nuclear proliferation, efforts to prevent the spread of nuclear weapons and materials. Historical events and discoveries. 66. Discovery of radioactivity, Henry Becquerel's accidental discovery of radioactivity in 1896. 67. Curie's work, Marie and Pierre Curie's isolation of radium and polonium. 68. Rutherford's experiments, Ernest Rutherford's experiments on radioactive decay and nuclear structure. 69. Nuclear fission, the discovery of nuclear fission by Otto Hahn and Fritz Strassmann. 70. Nuclear fusion, the process that powers the sun and stars. 71. Chernobyl disaster, a nuclear accident in 1986 that resulted in widespread contamination. 72. Fukushima Daiichi nuclear disaster, a nuclear accident in 2011 triggered by an earthquake and tsunami. 73. Nuclear Non-Proliferation Treaty, an international agreement to prevent the spread of nuclear weapons. 74. International Atomic Energy Agency, IAEA, an international organization that promotes the peaceful use of nuclear energy and safeguards against nuclear proliferation. 75. Nuclear Regulatory Commission, NRC, a U.S. government agency that regulates nuclear power plants and other nuclear activities. Detector manufacturers and suppliers. 76. Mirion Technologies, a leading manufacturer of radiation detection and measurement instruments. 77. Thermo Fisher Scientific, offers a wide range of radiation detection products and services. 78. Mirion Technologies, a leading manufacturer of radiation detection and measurement instruments. 79. Canberra Industries, provides radiation detection equipment for various applications. 80. ORTEC, a supplier of high-performance radiation detection systems. 81. Ludlam Measurements, offers a variety of radiation detectors and instruments. 82. Radilec, a manufacturer of radiation detection and monitoring equipment. 83. Bicron, a supplier of scintillation materials and detectors. 84. Amptec, a manufacturer of portable radiation detectors and spectrometers. 85. Seiko EG&G, a provider of radiation detection and measurement solutions. Detector accessories and components. 86. Shielding. Lead, tungsten, or other materials used to protect against radiation. 87. Collimators. Devices used to define the shape and size of a radiation beam. 88. Pulse amplifiers. Electronic circuits that amplify the electrical signals produced by detectors. 89. Pulse shapers. Circuits that improve the shape and quality of detector signals. 90. Multi-channel analyzers, MCAs. Instruments used to analyze the energy spectrum of radiation. 91. Data acquisition systems. Systems for collecting and storing detector data. 92. Power supplies. Devices that provide the necessary power for detectors and associated electronics. 93. Cables and connectors. Components used to connect detectors to other equipment. 94. Software. Computer programs used to analyze and interpret detector data. 95. Calibration sources. Radioactive sources used to calibrate detectors. Emerging trends and technologies. 96. Nanotechnology. The use of nanomaterials in radiation detectors for improved sensitivity and selectivity. 97. Quantum detectors. Detectors based on quantum mechanical principles for enhanced performance. 9. Continuing the 100 facts about radiation detectors. Emerging trends and technologies, continued. 98. Artificial intelligence, AI. The application of AI to analyze detector data and improve detection capabilities. 99. Machine learning. Algorithms that enable computers to learn from data and improve their performance over time. 100. Deep learning. A type of machine learning that uses neural networks to learn complex patterns in data. Additional facts. 101. Radiation units. Units used to measure radiation exposure, such as the Gray, GY, and CVIT, SV. 102. Radiation Protection Officer, RPO. A person responsible for ensuring radiation safety in a workplace or facility. 103. Radiation Emergency Plan, REP. A plan for responding to radiation accidents. 104. Nuclear Medicine Technologist. A healthcare professional who specializes in using radioactive materials for medical diagnosis and treatment. 105. Health Physicist. A scientist who specializes in radiation protection and measurement. 106. Radioisotope production. The process of producing radioactive isotopes for medical and industrial applications. 107. Radiation Therapy Simulator. A device used to plan radiation treatment for patients. 108. Radioactive Waste Disposal. The safe management and disposal of radioactive materials. 109. Nuclear Proliferation Control. International efforts to prevent the spread of nuclear weapons and materials. 110. Radiological Terrorism. The use of radioactive materials for malicious purposes. 111. Radiation Detection in Space. Instruments used to study radiation in space, such as cosmic rays and solar flares. 112. Environmental Radiation Monitoring. Continuous monitoring of radiation levels in the environment. 113. Radiation Detection in Food. Techniques to detect and measure radioactive contaminants in food. 114. Radiation Detection in Agriculture. Applications of radiation technology in agriculture, such as pest control and food preservation. 115. Radiation Detection in Law Enforcement. Tools used to detect radioactive materials in criminal investigations. 116. Radiation Detection in Homeland Security. Technologies for detecting and preventing radiological threats. 117. Radiation Detection in Archaeology. Dating artifacts and studying ancient civilizations using radioactive isotopes. 118. Radiation Detection in Geology. Using radiation to study the Earth's geological history and composition. 119. Radiation Detection in Oceanography. Measuring radiation levels in the ocean and studying marine ecosystems. 120. Radiation Detection in Meteorology. Using radiation to study the atmosphere and weather patterns.